Hello guys, welcome to Crown Smarts. In today's video we are going to deal with topology. So I'm just going to give a brief definition of topology and a topological space with some examples of topology. So let's begin. A topology is actually the study of the properties of shape and spaces that are preserved under continuous transformation, such as stretching, bending and twisting, but not tearing or gluing. So they are the study of properties of shape and also spaces, some spaces that are preserved under what? Continuous transformation. And these spaces are spaces that you can stretch them, or you can bend them, you can twist them. But if these spaces are being teared or glued, then you can't actually study the properties of it, because topology only depends on the stretching, bending and the twisting properties. So we also want to discuss the topological space. Topological space is a pair, actually is a pair consisting of the sets, is a pair consisting of the set X with its topology tau. Now X is a set of points called the underlying set or a space. Okay, tau on the other hand is a collection of subsets of X. So tau is the collection of subsets of X. Now let me remind you that those collection of subsets of X are open sets. So the tau is a collection of open sets, okay, that are subsets of X. Now it is called the topology or the open set that satisfies the following axiom. Now for tau to be a topology on X, it must satisfy the following axiom, and the axioms are three in number. The first axiom is that the empty set and the whole set must be in the topology. That's the first axiom. The empty and the whole set must be in the what? The topology. The second one is the union of any collection of sets in tau is also in tau. That means given any collection of sets in tau, the union of those collections in tau is in what? In tau. Now the intersection of any finite collection of sets in tau is also in what? In tau. So given any collection of sets in tau, any finite collection of sets in tau, the intersection or the finite intersection of those sets in tau is also in what? In tau. Okay, now we want to give some examples of topological space. Now these are some examples of topological space. We have the discrete topological space. Now this is where tau is equal to the power set. Remember, this instead denotes the power set of X. And what do we mean by power set of X? Power set is the set that is the collection of all subsets of X. Okay, that is the power set of X, the collection of all subsets of X. So this means that all subsets of X here are open. So all subsets of X are open in X. Okay, so this tau is the collection of all subsets of X. Now we also have the cofinite topological space. This is where the topological space is a collection of A, which is a subset of X, such that A is either empty or its complement is finite. So the collection of A is such that A is either empty or its complement is what? Finite. Also, we have the indiscrete or the trivial topological space. We can call it the indiscrete or the trivial topological space. This is where the topology consists of only two open sets, that is the empty and the whole sets. Okay, so it's the trivial or the indiscrete topological space. So whenever you have a topology that consists only the empty and the whole sets, then we know that this is the indiscrete or the trivial topological space. Now we also have the standard topological space. Okay, A standard topological space is the collection of A such that A is an open interval in R. Okay, the collection of A is an open interval. So this is the collection of all open interval in R, and those open interval is what are open. Okay, now we also have the subspace topological space. The subspace topological space now is also otherwise known as an induced topological space. Now, given this topological space, okay, and Y is a subset of X, then we say that this is also a topology. We also say that this is also a topological space. So this is a subspace topological space. This actually is a subspace topological space where this topology is defined as the collection of, this is the intersection of Y and open, this is an open set in this topology. This is Y intersects O such that O is in tau. Remember, O is coming from this topology. So for Y to intersect O means that that result is in this topology. It's open in this topology. Okay, we are going to do more of this in other videos, so you are going to understand better, but this is just an example just to show you that okay, these are topological spaces and there are more of them, so I just gave a few of these. Please don't forget to subscribe to this our YouTube channel, please, at Smart. Really appreciate if you subscribe to this channel. Thank you very much. And please, we're going to put and give more highlights on these topological spaces in the next video. Thank you very much.